So as reviewed, the difference quotient is limit as h approaches 0 of f of x plus h minus f of x, all of that over h, right? So how do we use this to calculate the derivative of, let's say, y equals x squared, right? Simple. Let's say y equals x squared, and we want to find the slope of this function when x is equal to 2. So find f prime of 2 equals what? And I don't know, maybe I shouldn't assume so much. So f prime of 2, f of 2 is just the value of that function, right? F of 2, it's simple. So when we add a prime here, we're talking about the first derivative. So prime is first derivative. And in general, number of primes equals the number of derivatives that we're applying. Number of derivatives. And another way of writing f prime of 2 is dy over dx at 2 with this bar, which means evaluate at what? At 2. Or we say x equals 2, but you know, that might be too much to write, so we just put 2. That's another way of writing it, dy over dx. And if dy over dx confuses you, it's okay. You'll learn what that the nuances of what that means later. So how do we do this? Well, if y equals x squared, so f of x equals x squared, that's the same thing. So this is equal to f of x equals x squared. So if we want to just strictly evaluate this, we should find f of x plus h and f of x and subtract them and see what we do, because direct substitution is going to lead to 0 over 0, because it's f of x minus f of x, because h is 0, f of x minus f of x is 0 in the numerator, 0 on the denominator. We get indeterminate form, just like any one of those other limited examples a couple of videos ago. So what do? We try and evaluate these, the numerator. So what is f of x plus h? So f of x plus h is equal to x plus h squared. Why? We just plug x plus h into x. So what is that? We FOIL it out, we get x squared plus 2xh plus h squared. Right? If you don't believe me, you can check. And what is f of x? F of x is just, well, that's just x squared. Right? Right. So we plug that into the difference quotient, and what do we get? We get limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared. All of that over h. And what do you notice? We can cross that out and we can cancel that. I'm going to take it one step further, and I'm going to say that the numerator now has an h in common, so I can factor out an h. So I'm going to rewrite this into limit as h approaches 0 of h, I'm going to factor out an h, 2x plus h over h. And now what do you notice? Well, those h's cancel out, so now we're only left with limit as h approaches 0 of 2x plus h. Now that we've canceled out that h in the denominator, life gets really easy. So now we can just use direct substitution. This h goes to 0. And what are we left with? We're left with this, 2x. And what did we say that this was? This thing right here? This is instantaneous rate of change, aka the derivative, right? So this 2x is actually our derivative. Derivative of x squared. That's really cool. We just use algebraic manipulation to, you know, do the derivative of x squared the long way. That's pretty cool. So now we can evaluate, so since f prime of x is equal to 2x, now we can evaluate x prime of 2, which is 2 times 2, which is 4. So the slope of x squared when x equals 2 is going to be 4. So let's try x cubed. X cubed equals f of x. And I want to find f prime of 1. Alright, so let's do the same thing again. Let's find f of x plus h and f of x. So what's f of x plus h? Well, that is f of x plus h is equal to x plus h cubed. I don't have that formula memorized in my head. Oh, sorry. So I'm going to split this up into x plus h squared into x plus h. So that's going to be x squared plus 2xh plus h squared. All of that times x plus h. And I'm going to FOIL this out again. It's going to become x cubed plus x squared h plus 2x x cubed plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed. Okay, let's see if we can combine any terms here. X squared h, 2x squared h, these are like terms, and those are like terms. So this is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. So that's going to be x plus h cubed, or f of x plus h. And what is f of x? Well, that's just x cubed. So now put it into our difference quotient. We're going to get the limit as h approaches 0 of this huge thing, x cubed plus 3x squared h plus 3xh squared plus h cubed. And you can see why people don't like doing derivatives using the difference quotient, because it takes so god-awfully long over h. So you can cancel out the x cubed, and I'm going to skip a step and factor out an h. So this becomes limit as h approaches 0 of h times 3x squared plus 3xh plus h squared. Hopefully I did that right. All of that over h. The h's cancel. Switch colors again. Limit as h approaches 0 of 3x squared plus 3xh plus h squared. Now the h goes to 0. What goes away? This goes away and this goes away. They all go to 0. So what is our derivative? It's 3x squared. And so when we plug in f prime of 1, that's going to be 3 times 1 squared, or 3. So the slope of the function x cubed at 1, x equals 1, is going to be 3. It's going to have the slope of 3. Okay, so that's cool. And I just want to note something, because it's going to be the theme of our next video, which is going to be power rule. And it's that if y equals x squared, y prime equaled 2x, right? And if y equaled x cubed, y prime was 3x squared. Do you notice a pattern here? So I'll tell you what the pattern is. the power moves to the coefficient of the x, and then you decrement the power by 1. So it becomes x squared from x squared to 2x. Similarly here, you brought the 3 over next to the x to become the new coefficient, and then you decremented the power by 1, so it becomes from x cubed to 3x squared. And you know, I'm going to leave you off on this. You know, y equals x to the 4th. You know, you could do the binomial theorem to figure this out, but it's going to take even longer. But you know, if you see the pattern, you might know the answer to this already. What's the derivative of x to the 4th? And if you say that it's 4x cubed, you're absolutely right. And what is, if y equals x to the 100th power, y prime is going to be 100 times x to the 99th power. You'd be absolutely right. You'd be absolutely right. And that's the power rule. And we're going to get into some more of those shortcuts and how to calculate derivatives a bit faster than the difference quotient next time.